I guess the key's in the name, Elasticsearch. You can break that up into two components. There's the elastic side, so it basically provides you with a server, a piece of software that you can run as a server. And the elastic side means that it will allow you to scale across a cluster of servers, so multiple applications.
Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the Geospatial community. My guest on the show today is Mark Varley. He's been on the podcast before. He comes to us from a company called Address Cloud, and he's going to be walking us through what Elasticsearch is, what we can use it for, and how we should be thinking about this in terms of geospatial. So one of my hopes for this podcast is to be able to introduce you to companies and individuals that are doing interesting work in the geospatial world and to new ideas. And today I want to introduce you to another idea, and this idea is called PlaceKey. So PlaceKey is a movement to create an industry standard for identifying any physical place. So think of placing a grid over the entire world and then having a unique identifier for every cell in that grid. So the hope is that if we can create an industry standard around how data is spatially joined, we can make it easier to combine data sources and create more value. So there's over 500 companies that are behind this idea of PlaceKey. They're backing the initiative. And if you are interested in it, if this sounds like something that you might want to know more about, go along to placekey.io and check it out. Okay, let's get into the interview. Let's talk about Elasticsearch. Hey Mark, welcome back to the podcast. I appreciate you taking the time. This was all on short notice, so it's much appreciated. Today we're going to be talking about Elasticsearch, and before we dive into that conversation, perhaps you could just take the time to introduce yourself, give us a little bit of an idea of your background, how you got involved in geospatial.
Yeah, thanks, Daniel. It's great to be back. I'm Mark. I run a company called Address Cloud. We're based in the UK. We provide geocoding and location intelligence services, predominantly to insurers, but more recently we're starting to work with some financial institutions, some banks, lenders, and some logistics companies as well. My background, I'm another one of these accidental geographers. So I started working with insurers probably about 20 years ago. I was working for a big consultancy at the time, and one of the first projects that I got put on was to basically help this insurer take GIS and geospatial analytics and bring it to the front of what they do. So embed that in the quote and buy process for an insurance company. So that was about 15 years ago, and that's what got me into geo. And then I started off my own business in 2015, and I've been doing it ever since.
Great. I love having accidental geographers on the podcast. So I mentioned before we're going to talk a little bit about Elasticsearch. Yeah, so let's just dive in. What is Elasticsearch? What is in the box when I download it, when I install it? What does it look like?
Yeah, so Elasticsearch, it's a mainly open source piece of software. As I say mainly. They have a commercial aspect to it as well, when there's some extra kind of bells and whistles that you get if you buy the commercial offering. But you can go on there, you can download it, and we use the open version. You download the software, and I guess the key's in the name, Elasticsearch. You can break that up into two components. There's the elastic side, so it basically provides you with a server, a piece of software that you can run as a server. And the elastic side means that it will allow you to scale across a cluster of servers, so multiple applications, and handle things like sharding, which is basically breaking your database down into chunks and coordinating all the replication across lots of servers. So we don't tend to get too much into that side. We use a managed service from AWS, and that just gets handled for us most of the time. And then obviously on the search side, that's the key thing, secrets in the name. So it provides you with a whole bunch of really cool tools and a really nice API and a set of kind of indexes and basically a set of tools to allow you to do search at scale. So across huge amounts of data in a very nuanced way.
Okay, so that's really interesting in itself. So we talked about how it scales, the elastic bit of it, and you focused a lot on the search side of it. So I'm curious now, is this actually a database or is this a search engine?
It's a bit of both, really. So it's not really kind of a full database. So it's that you wouldn't imagine it in the same camp as something like Postgres. But what it is, it's a distributed document store. So it deals with JSON documents. So, you could download the software. If you want to run it on your own machine, you go and do that today. You can download it from elastic.co. And basically, out of the box, you're able to start pushing lots of data in there. And then it provides you with a really nice API to then be able to query and search that data. One thing that's kind of particular about Elasticsearch is this concept of what they call an inverted index. And what that means is, unlike Postgres, where the first thing you do is you sit down, you say, okay, I need to create a table. What attributes am I going to put in that table? What indexes do I need? What's going to be my primary key? All of that kind of stuff. Here, you can get started out of the box. You can just start pushing data in there. And then what Elasticsearch will do is it will analyze those documents and say, okay, well, that looks like a date stamp. That looks like a piece of text. This one looks like a number, and this maybe looks like it could be a set of geometry coordinates, and it provides you that out of the box and just starts creating those indexes for you. So unless you tell it not to, it will index everything, and then you can then search on that.
Okay, so that's really interesting. Firstly, we now understand that this is JSON documents, you called them. So we push those into the database. It looks at those documents and says, okay, that looks like this data type. I'm just going to make that and index that. This is a geospatial podcast. So you mentioned before that if there's XY coordinates in there, does that mean that it'll see those and try and build geometries and make a spatial index based on that?
Yeah, depending on how you push the data in, it may do. It's quite possible. It's been a while since. So again, I think when you get started, the power in is this inverted index, that it indexes everything. What I'd recommend is probably unless you're doing the most basic use case, over time, you're probably going to want to go in there and tune and tell it and give it a bit more information about the indexes to help it out a little bit. But yeah, it provides. So they provide there's actually two different ways, two different spatial indexes that Elasticsearch supports. And apologies if during the podcast I talk about Elastic. Elastic's the company, Elasticsearch is the product, but they have other products available. But I might use those interchangeably. But yeah, there's two different spatial indexes. There's a GeoPoint and a GeoShape. Slightly confusing if you're coming from a Postgres background where you've just got this concept in PostGIS of a geometry in there that you can kind of create GeoPoints or GeoShapes or both. And there are advantages and disadvantages of each of those. But yeah, absolutely, it supports a spatial index, and there are a whole bunch of tools and kind of cool ways of using that spatial index.
I just want to stay with this comparison to Postgres. We mentioned that before, and I'm pretty confident that a lot of people listening to this podcast will understand the power of Postgres with the PostGIS extension in terms of spatial data. So if we stay with that one, for example, and do a little bit of comparing here. So when I think about Postgres, I think about structured data, right? I think about it's a relational database. I have a schema, I have my tables, I have foreign keys, which lets me build relationships between tables and query across them. So it's really flexible. And I also think about database management or data management. So I have all these functions that I can use to manage my data, to update my data. Is this the same over in Elasticsearch? Because we talked a little bit about it being more of a search engine than an actual database. So I'm curious, when I think about Elasticsearch and use cases, do I have to have a clearly defined use case, a clearly defined structure to my data before I start using it? Can I maintain it in Elasticsearch?
Yeah, you can. What people tend to do, and the same as us, so we use Postgres with PostGIS extension extensively, and we also use Elasticsearch extensively. I guess the difference probably would be that Postgres and PostGIS are awesome if you are going to be doing, if your use case is mainly GIS and you want to do a bit of search, then that's a great choice. And a lot of the things that you can do in Elasticsearch can be done in PostGIS. I think if your use case is mainly search and you want to do some geo, then Elasticsearch is probably a better choice. We use both, and that's the way we architect our services and choose which technologies we're going to use for which use case. And the other thing, I guess, about Postgres, and when it comes to doing queries and things like that, Postgres can be quite black and white. Elasticsearch is probably more nuanced and deals more with what we'd say shades of grey. There's a lot more power in there for doing some really, really complex search type use cases and search type problems, which would just be quite tricky to do out of the box within Postgres.
Yeah, and I think from the little bit that I know about this, that makes perfect sense as well. I want to talk a little bit about these JSON documents. You didn't refer to it as a database before. You referred to it as a document store, and we use JSON documents to put data in that, and that's what we get out, presumably, as a JSON. When we ask a question to this document store, we get a JSON response back. When I think about this and the little bit of research I've done around this, it seems to me that the document, we could think of the document in this document store as a row in a relational database, and we could think about the types of documents as being a schema, even though sometimes it seems to me that we refer to this kind of database as a schemaless database. Am I on the right track here, or have I misunderstood something along the lines?
Yeah, you would have been probably till recently. So Elasticsearch did have this notion of types, which I think that it was deprecated a couple of versions ago. And again, we had to do a bit of work to move our stuff over. I would say you could think of an index more like a table. So if you're going to be storing, let's say you're storing credit card transactions, the transaction would go in a table, would go in an index, sorry, and then you might have a separate index for your customer data. But what Elasticsearch doesn't do very well is handle joins and relation. So if your data is if you're used to a Postgres type view where you've got lots of different tables and you join them together, that doesn't work that well in Elasticsearch or any really kind of NoSQL databases with which you could put Elasticsearch as a kind of a specialist subset of NoSQL databases. You really be wanting to think about structuring your data as documents, more like you would see on the output or as the the thing that it actually relates to in the real world. Think of indexes as tables, and then within the index you've got your documents, and those would be your rows. Absolutely.
Okay, thanks very much for clarifying that for me and for the listeners. I think it'd be a really good idea now to move on and sort of talk about some use cases. We've mentioned a couple, but we haven't really gone into any depth. And I understand that in your business, you use this as as the back end for your geocoding services. Could you talk us through that? What does that look like? Why is Elasticsearch a great choice for something like geocoding?
Yeah, absolutely. So we've been using. So when I started the business in 2015, I did evaluate a whole bunch of different technologies, and kind of came across that Elasticsearch. It was recommended by a friend of mine. I had a look at it, and I just fell in love with it straight away. It was just perfect. It just felt like the right technology at the right time. And since then, I've gone on and we've seen quite a lot of other companies out there developing geocoders using Elasticsearch. It's a really good choice. I would say that just to be kind of a bit of air of caution, Elasticsearch will give you probably 80% of what you want out of the box. But you'll find yourself, if you're really kind of serious about geocoding and have a really good experience for your users, it's that extra 20% you have to really work at and really have to understand Elasticsearch well to kind of tune it to your requirements. But as I say, what it does really well is it allows you to combine full text searching, so complex searching fuzzy with things like fuzzy matching, dealing with typos and mistakes, along with more, I guess, this concept in Elasticsearch. Elasticsearch has a concept of queries and filters, so which they've kind of compressed those together, but still you have this idea of a query being more of a kind of a full text search, and then a filter being more of like a where clause that you get in Postgres. So you can combine that, but then also with things like Geospatial as well. The other thing it allows you to do out of the box, which we're becoming as users, we're becoming more and more used to it, is things like autocomplete or type ahead. And again, that's another very specific problem. And then finally, we also use it. So we use the geo indexes in there for things like reverse geocoding. So here's a coordinate. Give me all of the addresses within X meters of that coordinate, ranked by the closest first. It does all of those things really well and really, really fast.
Okay, so we're querying these JSON documents. We're sending in a query to the document store. We're getting a JSON response back. In this case, we're talking about geocoding. Does everything I need have to be in those documents already? And I guess what I'm talking about here, that the street name, the address, the county code or the country code, do I have to have a geometry already when I post that or get that into the document store, or can I calculate that on the fly? We talked earlier about Elasticsearch recognizing things that looks like a date, that looks like this kind of attribute, and creating a type based on that. Does that need to be made already, or can I calculate that in the database?
You'd be better. So Elasticsearch doesn't tend to. So it's all focused on getting you a response, getting you hopefully a relevant, accurate response very, very quickly. And the way it does that is it does all of its indexing and all of its optimizations in advance. So it's not particularly good at calculating things on the fly. You can do it. I mean, there's a scripting language that you have in there, and you can calculate things on the fly. But it tends to be better to do that in advance. What you can do though is if, for example, you've got a new attribute. Let's say you started wanted to record counties. So, like in the UK, for example, the Royal Mail don't recognise counties, but users often still deal with counties. So if we had a requirement to like start storing counties, we could just add those counties into our Elasticsearch document, and Elasticsearch would recognize those and index those using whatever it thought was the correct default settings. Again, counties and streets, you mentioned streets as well. Those are really good examples. So one thing that's really important is as users we often abbreviate. So street might be ST or road might be RD. Counties in the UK, you might have something like Worcestershire, which would be Walks, WORCS, all of those kind of things. So Elasticsearch has this concept of sort of abbreviations, alternates, or synonyms, as it calls them, and it's pretty clever. So you can give it a list of synonyms. You can add that into your indexing settings, and then when you add your documents in, if it sees Worcestershire or road or street, it will store not only the full version but also the abbreviated version, and that allows you to be able to deal with all of the kind of weird and wonderful ways that humans talk about addresses, which otherwise would be really, really difficult to do, or just quite complex to do in something like Postgres.
Yeah, it sounds like a much more human sort of centric, human friendly way of searching. That's for sure. What about more sort of complex things? So it's one thing to say, show me this to do geocoding. I'm living on the street. What is the point, the geographic point associated with this street name and with this address that I'm searching for? What about show me queries like show me things around me, close to me? Show me the best, I don't know, restaurant for a particular kind of pizza, for example, around me. Is it possible to do that kind of thing in Elasticsearch?
Yeah, absolutely, and that's quite a common use case for it. So we don't tend to, and actually on that note, so some of the examples of people using Elasticsearch, a big user of Elasticsearch is actually Tinder. So I guess if you're trying to find a date or mate within within your sort of local area, meeting certain criteria and etc. Tinder use that. They basically power their platform and all their search, or at least they did on Elasticsearch. So yeah, that's a great example. And yeah, things like this is so that again here when you're combining lots of different sort of search facets with some geo as well, it works really well. So I think there's a great blog post we can maybe stick a link in the show notes where they're kind of saying, show me all the restaurants that mention Italian food that were within 1 kilometer that are open at 11 p.m. with at least 4 stars and sort them by price with the closest first. I mean, you could break that down. There's a whole bunch of different things happening there, and Elasticsearch will just chew up that kind of query is perfect for something like Elasticsearch. There's an element of location, there's an element of distance, and then also Italian food might be pizza or it might be lasagna, spaghetti. Although you can basically use synonyms to look out for all of those kind of things as well. So it's a really really good use of the technology.
I think you mentioned this before, but it really does sound like Elasticsearch is, searching a search engine first with a little bit of geo attached to it. Like, still obviously an incredibly valuable tool for this kind of thing, but it feels like that it does full text search amazingly well, and perhaps the geolocation side of things is perhaps we should be thinking that as a way of filtering those search results. Do you think that would be a fair statement?
I think traditionally, yes. So that's where it's come from. So that was certainly the background. And initially there was fairly limited geo support. So as I say, you had this geo point index. That was the first geo index that was supported, and that's really optimized for geographic sorting, for bounding box queries and filters, radial searches, things like that. But actually, over the last kind of
4 or 5 years,
there's a guy, Nick Nyes, who runs or did at least run Elasticsearch's Geoside. He's come from a much more technical geographic background and has introduced a lot of what you'd sort of see in PostGIS, for example. So Elasticsearch will support shapes. A lot of the kind of queries that we do within PostGIS are now actually supported in Elasticsearch, and there's been huge improvements on the performance of those. it's not up there. It's not a full. I wouldn't put it in the same category as PostGIS with the kind of richness of the functions you can do, but there's a lot more you can do. So things like point in polygon queries and polygon intersects and disjoints and all of that kind of stuff, you can now do those in Elasticsearch as well. The other thing as well, as I say, we don't tend to use that a lot at the moment, but we're getting into it. The other thing that Elasticsearch is really powerful for, so a lot of people do use it for search, but probably the most common use case for Elasticsearch outside of the geo community would be log analytics. So a lot of the big logging software and logging software that you might use will be using Elasticsearch. And the power there is taking millions or hundreds of millions or even billions of records and being able to search those, filter those, and aggregate those on the fly. And Elasticsearch has some really cool geo aggregations as well that do that, but then maybe bucket it by geo hashes or tiles and things like that, but does it very, very, very quickly.
Because JSON is such an integrated part of this. I mean, that is the thing, that is the data format we push into the document store, and that's the thing we get out again. It really feels like this is built for the web. Would you agree with that?
Yeah, absolutely. Yeah, definitely. And I think that, one of the sort of, I guess, principles of the NoSQL movement anyway was, kind of what goes in is what you get out, if that makes sense. So, if you think about, let's say, sort of 5-10 years ago, we'd want to do some sort, let's say it's IMDb, and you want to have, this is the description of the movie, it's the rating, here's a bunch of reviews. Often that might involve lots of calls to a relational database, joining together lots and lots of tables, bringing them all through, showing them on the screen, and then taking those updates, propagating them back down, splitting them all up again. It was quite a lot of work. So yeah, I guess for NoSQL, having this concept of representing data as an object in this almost in the same way that it's going to be presented is absolutely fundamental to that. And again, Elasticsearch is no different. So it deals in documents rather than tables and relations and the kind of things that we think about from a more traditional database background.
Earlier, you talked about the improvements, I guess you could call them, that are being made to Elasticsearch in terms of geospatial, in terms of supporting some of these geospatial functions we see in the Postgres world, for example. Where do you think this is going to go in the future? Should we expect to see more and more of this? Or do you think Elasticsearch will sort of always be search with a little bit of geo?
I think they're doing fantastic. I think it's kind of almost a bit of a hidden secret amongst the geo communities. At least that's what I feel. I mean, I go to FOSS4G. I didn't this year, because of the COVID, but normally I go to the FOSS4G annual conference every year. And I taught an Elasticsearch workshop about four years ago in Bonn. And at one point there was quite a lot of Elastic things coming out, and within geo community, but it seems to have gone away a little bit. So I think people have. I don't know why, because I think it's really awesome. I think people maybe struggle a bit to get their head around this GeoPoint, GeoShape, and it looks like they've actually introduced a new spatial index in the latest version. But I think it's a really powerful toolkit. So we've got a use case that we're working on at the moment, and are hoping to have something launched kind of towards the end of the year around for the insurance industry around exposure management. And what this involves is, imagine an insurance company, they might be insuring, let's say, 5 million properties or buildings potentially anywhere in the world, or anywhere across Europe, and they want to be able to see those on a map, see where their hotspots are, so where they might have a lot of exposure, as they would call it, so or where they basically have a lot of properties insured in one place, and then intersect those with things like where there's high flood risk or high crime, or maybe a higher wildfire risk. And at the moment, that's something that in traditional geospatial, that's quite hard to do. You're dealing with a lot of points like that. And again, I think Elasticsearch, which we're looking at that at the moment, actually using Uber's H3 index as well. So as we bring the data in, we enrich it and tag it with Uber's H3 index, and then that allows us to do that kind of use case really, really quickly. So we've got the whole power of looking at being able to deal with millions of documents. We can use the spatial indexes for things like intersecting with flood boundaries or wildfire boundaries. And then finally, we can use the aggregations to aggregate up by either an Uber H3 cell or some sort of admin boundary really, really quick. We built together a kind of demo on that, and it's really exciting. So yeah, I would urge any kind of geo people out there, if you're doing with that kind of use case, so lots and lots and lots of data, maybe not the most complicated geo stuff in the world, but lots of data, and you want to visualize that and you want to aggregate it up, I think definitely worth having a look at Elasticsearch for that as well.
Yeah, it really sounds like Elasticsearch is built for that kind of the back end to these dashboards that we're seeing everywhere nowadays. And I think that the magic of a dashboard is that it displays a whole bunch of data in a way that people can understand it. They're not necessarily the most complex in terms of the analysis that you can do in a lot of the dashboards that I've seen anyway. But the idea is to get that data out to the users in a way they can see it and understand it and make decisions based on it. And what you just described there sounds like a really, really interesting use case.
Yeah, absolutely. And one thing that's worth noting as well. So Elasticsearch, we talked about Elasticsearch extensively, and I mentioned briefly earlier about there's Elastic, the company, versus Elasticsearch, the product. There's a couple of sister products of Elasticsearch that are often you might hear people refer or see things referring to the ELK stack, so ELK, and that's Elasticsearch, Logstash, and Kibana. And those other two products work really well with Elasticsearch. So we talked about dashboards. Kibana is basically like a front end to Elasticsearch. So Elasticsearch out the box, all you get is you get download the software, it runs in the background. You pull up port 9200 and you've got an API there that you can start using. What Kibana does is it points to your Elasticsearch installation and gives you a whole bunch of really powerful, really cool dashboarding and widgeting capability in front of that. And it does support geo and maps as well. So you can, let's say you start ingesting a whole bunch of log data or a bunch of addresses and you put a geo point on them, you can get a really nice visual view. You get lots of cool graphs and charts, but also a map showing and representing some of those geo aggregations that I talked about. And again, that's all free. That's all available for download out of the box. And then finally, Logstash that I mentioned there as well. That's quite a nice way of building pipelines. So often we talked earlier around Postgres, and often Postgres might still be your system of record. You might be wanting to build some sort of pipeline to take your data from Postgres, transform it, tag it maybe along the way, and then put it into Elasticsearch. Again, Logstash is another part of the toolkit that allows you to do that and do that very easily.
So in terms of that, moving data from Postgres to logs or to Elasticsearch via Logstash, so what we're thinking about there is using Postgres as the database management side of things, and when we have the data in the shape that we want it in, we export it out, for want of a better word, through Logstash and then over to this document store. Is that the correct way of understanding this?
Yeah, absolutely. So yeah, Logstash is a tool that will help with that and do that out of the box. It would also have adapters for things like Apache and Nginx and lots of other. The list is as long as your arm, and there's add-ons and plugins that you can do as well for any data source. So that's a really good way of doing it. I have to say, for our own requirements, we found Logstash possibly a little bit heavy because we tend to move data over. We deal mainly with addresses and data that maybe updates once a week or maybe once a month. So we actually wrote our own scripts for doing that. But Logstash is a really good way, particularly if your data is quite dynamic and is changing all the time. Logstash gives an excellent solution for that.
Just, I asked a little bit before about the future, and we talked a little bit about what what geospatial functionality we might expect to see. And you mentioned that it was a little bit of a secret in terms of the Elasticsearch community. But I'm wondering, in terms of use cases, is there any sort of use case out there that you can see at the moment that is just screaming out for Elasticsearch?
Oh, that's a tough one. Off the top of my head, I can't think of anything out for the top of my head. But I would just say, yeah, as I mentioned earlier, definitely think the geo community should look at Elasticsearch in a bit more, in a bit more detail to understand a bit more about what it does. It's something they're working on all the time. There's actually a maps interface. I think they've now got an Elasticsearch maps tool. We haven't used it personally, but yeah, it's well worth a look. And if you're doing lots of search or lots of aggregation, or you're starting to run into some restrictions or things that you think you might be struggling with your Postgres database or whatever, maybe it's worth a look.
Mark, I really want to thank you for your time today. Again, this was very last minute, so I really appreciate that you took the time to come along and teach us all a little bit more about Elasticsearch, how we might implement it, some of the use cases that it would be suited to. It's been a really enlightening conversation. Before I let you go, where can the listeners go if they want to reach out to you, if they want to continue the conversation, or perhaps learn more about the work that you're doing?
Yeah, sure, absolutely. So if you want to find out about Address Cloud, we're addresscloud.com or at Address Cloud on Twitter, and you can find us on LinkedIn as well. And then for me, yeah, best place to find me is on LinkedIn. I'm Mark Varley, that's Varley on LinkedIn, and I'll be happy to contact and connect with you.
Thanks again, Mark. Much appreciated.
Yeah, thank you, Daniel. That was great. Cheers.
And that's it for another episode of the Mapscaping podcast. I really hope you enjoyed that interview with Mark Varley from Address Cloud. I think that Elasticsearch sounds like an incredibly interesting product, and it has a ton of applications in geospatial, especially, at least in my opinion, when I think about using this on the web. Right at the start of the episode, I mentioned PlaceKey. So this is a movement to create an industry standard for identifying physical places. I think this is going to change the way we do spatial joins. It's going to change the way we combine data sets, and I really think it's worth investigating. If you are interested, go along to placekey.io and check it out for yourselves. As always, you are more than welcome to reach out to me if you have any questions or suggestions or feedback about the podcast. I would really love to hear them. You can find me on social media, LinkedIn, all of the places. Also have an email list, and you are more than welcome to join that and reach out to me there. There'll be a link in the show notes if you're interested. If you haven't already, consider subscribing to the podcast. This is a weekly podcast. There'll be a new episode out next week. And if you're subscribed, it'll automatically show up in your podcast feed. That's it from me. See you again next week. Bye.